Solve exponential and logarithmic equations. Exponential equations are equations in which variable expressions occur as exponents. Example, let's solve 4 raised to the x plus 1 power equals 64 raised to the x minus 3 power. Well, first let's change the 64 so they both have the same base. So that would be 4 to the third power, 4 cubed. And now a power raised to an exponent can be written as a single power if we keep the base and multiply the exponents. And now you see that we have the same base, and we could just set the exponents equal to each other. Or we could also take the log base 4 of both sides, keeping in mind that this would occur because log base b is the inverse of an exponent with the same base. So that would look like this. And applying the property I just underlined, this would cancel out and we would be left with the exponents. Alright, so now we just have a linear equation we have to solve. Subtract x from each side, add 9, divide by 2, and we get that x equals 5. Let's check x equals 5 by substituting back into the original equation. And we end up getting that both sides are equal, confirming that x equals 5 is the answer. Let's try another one. So 3 to the x power equals 1/9 raised to the x minus 3 power. Alright, first, 1/9, I can change that to an exponent with a base of 3. So 3 squared is 9. So therefore 3 to the negative 2 power will be 1/9. You can see that right here. Alright, same thing as before. We keep the base and we multiply the exponents. So we get 3 on the right side raised to negative 2x plus 6. We could set the exponents equal to each other, or we could take the log base 3 of each side. Either way. So this cancels out. And again, cancel is a blanket term, so make sure you understand here what it means. We're following, the fact that they're inverses. I end up with a linear equation. Add 3x, divide by 3, and we get that x equals 2. I can check this one by graphing. So I'm going to graph the left side as y equals 3x and the right side y equals 1/9 raised to the x minus 3 power. And that indeed confirms that they intersect when x is 2. Example, solve 7 to the x power equals 100. We know that 7 squared would be 49. And 7 to the third power would be 343. Therefore, our answer has to be, for x, our answer has to be between 2 and 3. All right, to do this, we're going to take the log base 7 of each side, which looks like that. And on the left side, we will be left with x. And this is actually the exact answer. However, usually the answer is approximated, so we could either type that into the calculator or use the change of base formula. The numerator is 2, denominator is a little less than 1, but just use the calculator, you get approximately 2.367. If we check the approximation, we get 100.08. That's telling us that it is correct. It's not exactly 100 because we approximated. If we check the exact value, well, then we substitute back into the original, and since exponents and logs with the same base are inverses, this cancels out, and we're left with 100 equals 100.